Hello everyone, and welcome to part 2 of the Data Capstone Project Solutions lecture for the 911 Calls Capstone Project. Let's go ahead and jump right where we left off and go to the Jupyter Notebook. Okay, here I am at the notebook. Right when we left off, we discovered that the months were actually missing a couple values. For instance, 9, 10, and 11 were missing. And what we want to do is now work with pandas to try to create maybe a line plot or some other visualization that tries to take that into account. So maybe we can fill in those missing data points. Okay, what we're going to go ahead and do is create a group by object called by month and say df group by, pass in the month column, and use count method for aggregation as asked for in the directions. And then let's go ahead and just check out the head of by month. Okay, and here we can see the head of by month. You'll notice that basically what happened was we counted every instance of the columns by the month. What we're going to go ahead and do is notice that some of the counts are different depending on the actual column value. And that's because some values are essentially missing when you aggregate it by month. What we're going to go ahead and do in order to even everything out is just choose the latitude column as our value for the aggregate count. We'll go ahead and assume that if we had the latitude of the call actually took place. Then we can create a simple plot off the data frame indicating the count of the calls per month. And the way we can do that is actually just by plotting out the column. So we say by month, call the column, for instance, latitude, and then say plot. And here we have our month. And now we've actually been able to fill in some of that missing information through essentially a fit between point at 8 and point at 12. And there you can see the down curve maybe a little better than you would have been able to had you done it with just a bar plot. And to show you that maybe in a little more detail, I'm going to go ahead and copy this code, paste it here, and I'm going to go ahead and remove the hue. And then if I run this, we will see the code here. We have month. Don't worry about this little warning. But this essentially shows the same information, however, without the 9, 10, and 11 month. So you can see the drop down from month 7 to months 8 and 12. However, maybe it's a little more clear, the drop down between 8 and 12, using this sort of line plot. And you can actually play around with which columns you choose to plot, such as maybe the township column or the zip column, etc., to see how pronounced this drop is. This is kind of that area of exploratory data analysis where maybe there isn't an exactly correct answer, unless you want to show something very specifically through quantitative methods. And in that case, you probably would show this sort of bar plot. But it's also nice just to get an idea of the trend using just a simple plot command. All right, let's go ahead now and see if we can use Seaborn's LM plot to create a linear fit on the number of calls per month. And keep in mind, you may need to reset the index to a column in order to do that. What I'm going to go ahead and do is say this. I'm going to say sns.lm plot for that linear model plot from Seaborn. And I want my x, if we go ahead and check this out, to be month. And we can go ahead and now select maybe townships for the y-axis. You can also select latitude or really any other column if you want to kind of experiment around with this, since it essentially just counts. And then the data is going to be the by month. But notice here, I said X is the month column. If we take a look back at the by month, we don't actually have a month column. The month was the index. So what I'm going to go ahead and do is reset the index to month in order for this to work. And to make it even more clear, let me just show you what this actually looks like. If I reset the index on the by month, I will make month into a new column, and that allows Seaborn to actually access this information instead of setting it to the index. And that way I can actually pass in month here as a string. Otherwise, Seaborn would get confused. And that's why we had to use this reset index to the column. And there we get the linear model fit. And we can see that generally, as far as what Seaborn kind of plots out in this model, that the number of calls goes down from 0 to month 12. Now keep in mind, Seaborn doesn't have enough information to realize that this is by month, and so that 13 and 14 shouldn't actually exist or continue. This would actually be seasonal data, and in that case, probably a linear model isn't actually the best fit, and you can see that Seaborn kind of tries to show this with this shaded area indicating error, and the error basically grows as you go into these months where there's less information known, which actually makes a lot of sense since you didn't have information about 9, 10, or 11 months. And you kind of see this weird trend where it goes down, starts to come up, and then crashes at month 8. And that's something you may want to explore later on in the data. But let's go ahead and just leave it at that for now and explore a little bit more about the dates information. Okay, what we wanted to do next was create a new column called date that contains the date from the timestamp column. And you'll need to use apply along with the date close parentheses method. Let me go ahead and show you what this actually means by date by showing you an example of the timestamp column. I'm going to go ahead and just grab the first instance of the timestamp column and call one of those objects. All right, this is a timestamp object, and it's a little different than actually a date object. And the reason for that is if I call t.date off of it, I would now get a date object, and this just shows the date information. It no longer has the time information. And that's good because what we're going to want to do later on is create a plot that looks like this, just the number of calls per date. We don't want to flood this with two information with number of calls per every minute or every hour. All right, and that means let's go ahead and say df date is equal to df of timestamp. And just like we did before, I'm going to go ahead and apply this with a lambda expression. I will take that time, t, and return t date. I go ahead and apply that. And now if I take a look at df head and go all the way to the right here, now I have this nice date column, which is driven off of this timestamp column. And then what I'm going to go ahead and do is group by this date column with the count aggregate. So I'm going to say df date, actually I'm going to say df.groupby, pass in date, that's what I want to group by. I'm going to go ahead and count, and then let's just go ahead and see the head of this data frame, what this looks like. Okay, and this essentially counts all the instances per date for the actual day that occurred. Again, notice that there's some difference between some of these column values, and that's just basically indicating that you were missing some information. For instance, out of the 396 calls on December 11th, or depending how you want to read that date, whether it's, this should be December 11th, you only had 333 with the zip code versus 396 where you had the latitude. Let's go ahead and just choose one of these columns. It's kind of arbitrary since they're actually all pretty close to number, but I'm going to go ahead and grab the latitude column, and you can experiment by grabbing different columns, how they compare. And here I have the latitude column, which now basically gives me a date and the count of number of calls where we knew the latitude. And then I can go ahead and just plot this out. And it gets me a plot that looks like this. And notice we get some of these labels overlapping. And what we can do is say plt tight layout, as we've shown before, in order to actually kind of fix that index and get something that looks a little nicer. All right. And then what we actually notice here is it looks like there's some significant spikes in February and a little bit in March, and then we get some downturns or some bottom out spikes in May and maybe late August. A little hard to tell here. And you can go ahead and mess around with this plot or extend the plot to try to get a little more information about the actual dates. What we're going to go ahead and do now is recreate this plot, but create 3 separate plots with each plot representing a reason for the 911 call back to the reason data frame, or excuse me, column. Let me show you what I mean by that. So if I scroll down here, we want to recreate this plot. So here we have one plot with only the traffic calls, only the fire calls, and then only the EMS calls. And what we do is actually a very similar process to what we did here. So I'm going to copy and paste this. But instead of the entire data frame, I'm going to use conditional selection to actually do the group by. So I'm going to say df, where df of reason is equal to, and the first one we can just go ahead and say traffic. 2 F's there. And then we go ahead and plot this. And there we have the plot for traffic. And if you wanted to, you could have also said PLT title and indicated you want the title to be traffic. And now we can actually just use this same code to perform the other charts. So if we wanted fire, we just replace this with fire as the reason. And now we're able to take advantage of all the work we just did previously to create these 3 separate plots. And you can go ahead and kind of explore them on your own and see if you can find differences between maybe number of calls or frequency of calls during the dates. For instance, it might be interesting to see how weather would affect fire based off the month or the day. You can see there's some interesting spikes there. Okay, moving along, let's finally go to creating heat maps with Seaborn and our data. And first what we're going to need to do is restructure the data frame so that the columns become the hours and the index becomes the day of the week. There's actually lots of ways to do this, but what I would recommend trying to do is using group by with a new method that I wanted you to discover called the unstack method. And there's a link here to the documentation, and you can refer to the solutions if you get stuck on this. Let me go ahead and break down how to actually make something that looks like this heat map. Remember, back to the cluster map and the heat map lectures, we need our data to be in what's known as matrix form, where every single cell converts back to a value representing the value at the column and the index itself, meaning at hour 0 on Fridays, this is how many calls occurred. Okay, let's go ahead and learn how to use the unstack method. And there's some examples here in the documentation, which hopefully you may have discovered on your own. But if you got stuck on it, no worries, because I'm going to show you how to do it right now. We're going to go ahead and say df group by, and I'm going to have to group by a list in this case, because I don't want to just group by day of week. I also want to group by hour. And then what I'm going to go ahead and do is say count. Let's just go ahead and take a look at what this looks like. And this basically allows me to group by and create a multi-level index, day of week, and then the hour, and then just the counts for each column here. So I have this multi-level index. What I can do now is just call a singular column off of it, maybe reason. We can go ahead and do that. And now I have this multi-level index, and the key to the unstack method is it basically allows you to unstack this and make this into a matrix form. And now I have this matrix form. So the steps were grouping by multiple columns, creating that multi-level index, and then being able to use unstack to essentially unstack that index and create one of them to be the columns and one of them to be the index. All right, don't worry if you got stuck on this or had trouble with this. This is actually a very kind of advanced method in order to do this. There's other methods you could have tried, such as using a pivot or a pivot table of pandas. Kind of up to you, but again, don't worry too much if you weren't able to do this. This kind of comes a lot with just practice experience and being able to look stuff up in the documentation. But we'll go ahead and call this entire data frame day hour. And now that we have that data frame, I can easily create heat maps. And this part will actually be pretty straightforward. We just call SNS heat map, pass in day hour, and that's essentially all we have to do. Now we get day of week versus the hour, and then the number of calls as the color indicator. And we can continue to try to make this look more like the solutions by saying CMap, passing in Viridis, and now we get the same color scheme as we do in the solutions, and we can make the figure a little bigger by saying plt.figure and adding in fig size as an argument. And now we have basically what was in the solutions. And now we can also create a cluster map with this data frame in very much the same manner by saying SNS cluster map, and again just passing in the data frame we created, day hour, CMap, Viridis. And that creates this same cluster map. If you're confused on what's actually going on this line, feel free to post to the Q&A forums, and I'm happy to explain this a little more. But just keep in mind this is kind of advanced, and if you got stuck, don't worry if you reference the solutions. Moving along, what we wanted to do is repeat these same plots and operations for a data frame that shows the month as the column. I'm going to go ahead and just copy and paste this from the solutions because it's essentially the same code as we just did above, but in this case, instead of saying, for instance, the hour, we just said the month. And if we go ahead and check that out, now we have day, month, and we essentially just make the same plots again. So we just go up here, call heat map, scroll down a bit. Instead of day, hour, I'm going to use day, month. And that gets me this heat map. And if I want to create a cluster map off of this, I can do the same thing, except just call cluster. And this creates a cluster map. So hopefully now I can actually explore the data and see maybe what hours of the week during what days of the week are the most popular for 911 calls to occur. And if we just take a kind of a brief look at this, it makes sense that not a whole lot of calls are happening between hours of 0 and 5 because that's essentially midnight to 5 in the morning, so everyone's asleep. Most of the criminal activity or reasons for 911 calls, such as traffic accidents, EMS, or fire, there's not really that much criminal activity in this data set. It's mostly fire, EMS, and traffic reasons. Those all tend to occur during the daytime. And what's interesting is that not too many of them tend to occur on Sundays and Saturdays. And you can actually see this a little clearer with the cluster map. So this will actually create clusters where it thinks there's low amounts of calls versus high amounts of calls. And sometimes what's nice for cluster maps is to choose something like the cool warm color mapping in order to really see this. And sometimes this is a little more clear of a color scheme for people to actually get the groupings in their mind. It looks like we have high calls during Wednesday, Monday, and Tuesday, and maybe Thursday and Friday during the hours 8, 16, and 17. So a little more towards the evening it tends to look like. Versus low call amounts are during maybe Saturday and Sunday in the morning. Okay, and then we just repeated those operations per month, and you can kind of compare summer months versus winter months here. And you can continue exploring the data however you see fit. And that's basically all there was to this capstone project. I hope you enjoyed it. I hope you found it interesting. Again, don't feel bad if you had to look up the solutions for this kind of complex one-liner here. You can always feel free to post it in Q&A forums if you need any clarification on what was actually going on there. All right, feel free to post for any questions whatsoever, and I will see you at the next lecture. Thanks everyone. Hope you enjoyed the project.